Here today, I have a slide where I'll kind of walk through the goals of today, but we're going to talk mostly about test-driven development. Can y'all hear me okay? I know I normally don't talk very loud, so this is like, I'm using my projected voice. My mom taught me when I was a kid. She was the choir director. So, but I'm Patrick, as Jesse ascertained, or as he shared, and I work at a place that's in Iowa, in the middle of nowhere. Not really, but Des Moines, Iowa, if you've never heard of it, it's in the middle of Iowa, pretty much. I don't live there. It gets really cold. I do like to be here in a nice warm climate, but I do like the occasional snow. So I like to go up there every once in a while. But what I'm going to talk to you about today is what I do on a daily basis when I'm working, sometimes on my pet projects. But we're going to talk about test-driven development. Also, if any of these slides or any resources that I have, there's a slide at the end that has a QR code so that you can get everything that you need. But yeah, my goal or the agenda today is to kind of talk about what is test-driven development, because I know that not everybody probably knows what test-driven development is. We're going to get into that, what it is, why I recommend it, and also some of the testing definitions. I know that testing, there's a lot of different definitions around what testing is, what kind of testing, what testing to actually do. So we'll get into some strategies, also how to structure some tests, and then also answer the question, what do I test? You might be surprised it's not really a definitive answer, but I'm going to give you a guide on what to test. Also talk a little bit about front end and back end. So like the database and the UI, specifically some tooling at the end as well. And then if there's time, we'll do a little bit of a demo if we can. The demo, I will say, is in C#. I didn't know what language to choose, so I just chose the one that I use day to day. So I can explain things if we get to the demo. If we do have time, I can kind of talk through like what C#'s doing here if somebody is not familiar with it. But just going to give a little example if we have time. So the goals, so we had the agenda of what we're going to talk about. The goals are learn how to apply TDD to the front end and the back end. I know that TDD, I know in my journey, the front end was always the more difficult one, because sometimes it's like, hey, like, do I test that there's a button there? Do I test what the button does? Do I care that the button's blue? Like, what do I really care about on the front end as far as testing? And also TDD, we'll get into what that is to learn what to test and what not to. And then I like this one, learn best practices asterisk for writing tests on the front end. And the asterisk just means when I say best practices, it's just my opinions. I said I'll try to be as unopinionated as possible, but I will have some opinions. And we'll probably find a better way in the future. So what I say today is what I do and what I recommend today, but that could easily change. I mean, there's a new framework for JavaScript like every week now, maybe, but all the front-end developers probably would get that one. So my bad. I'll have a better joke later. Don't worry. So testing. Why do we write tests? Sometimes this question it feels obvious, but we definitely want confidence that our application works. That's really the meaning for testing, is like, we don't want to be paying millions of dollars for an application to be developed and then it gets out there and it does nothing. Not to get political, but remember a few years back, healthcare.gov, when it got released and like nobody could use it, probably could have used some testing. So, but also we want to minimize the manual work. I mean, how many here, if you have done testing with your code, you like write the code and then you push it out into like some kind of staging environment or something. And then you have to go and manually check it to see that it did the thing that you programmed it to do, or even locally on your own computer. Like you're writing the code and then you go and I have to go submit a form, and then you have to go fill out all the details on a form and make sure that, when this status is set to this, it goes to this database and all that stuff. It can get pretty tedious to do a lot of manual testing. There is a place for manual testing, but I would like to say automated tests, I think, add more value than doing everything manual. That is probably one of the opinions I will definitely say is I value automated tests. I do value manual, but automated, if you can run it in a pipeline, that's instant feedback versus waiting for somebody to get time, maybe on their lunch break, or to go and manually do it. Also, tests document the behavior. I had a mentor once call it compilable documentation. I know that this is kind of a controversial topic. I'm not going to take a side on it, but I will say I value, if you look at the Agile Manifesto, working software, we value that. I think we value working software over extensive documentation. That doesn't mean that we don't value documentation. It's just that working software is what's going to make the money. Like working software is the true value. You may hear me say make the money, or the money is here. You can also insert the phrase value or the word value there. I usually speak with the word money because whenever you're talking to a lot of product owners or business, like when you say business value, or if you say like, this is what's going to make us money, it helps when you realize that it's actually making money when the software gets out. The longer we wait on it doing manual testing, it's a bottleneck. So some testing definitions. There's different types of tests for different types of things that you're trying to test. If you're familiar with unit tests, I feel like this tiny little word gets a bad rep, but also I think it gets very misconstrued. There's an author slash software developer that I don't know if y'all have heard of him. His name's Roy Osherov. He wrote the book, The Art of Unit Testing, and it talks about what a unit test is, and it tests a unit of work. But a unit, the word unit, like an inch is an inch. It's a measurement. And so like it's almost atomic. So unit tests tend to be small. We'll get into that a little bit more here in a little bit. Integration tests. This one also gets a bad rap because I think a lot of times people will write a unit test. They'll say it's a unit test, but it'll actually be an integration test. An integration test is when you connect two different or more, or I should say when you have something testing one or more other dependencies within the test. That's a little bit broader definition. Sometimes it can be multiple, like you can be going all the way down to like the database from a service layer. If you got a repository layer, if you're using a repository pattern, an integration test connects multiple layers, whereas the unit test is the smallest layer. So we go up to integration, and then there's end-to-end. End-to-end is technically an integration test, but end-to-end is like if you were to go to, like, if you're familiar with Cypress or Playwright or these other automation tools that I'll talk more later about, end-to-end is more of like the experience throughout the system. So like end-to-end, like let's say you have a website where somebody has to fill out an application for a loan. Well, end-to-end would be either the manual test or the automated test would go through and fill out all the information and then apply for the loan. And then you check and see, do I have a application in my system? That would be end-to-end. The whole thing works. There we go, end-to-end. And there's more: load, stress, smoke. I won't really be getting into load and stress and smoke tests and the et cetera on this one. But the main three that we're going to look at are really mostly unit, integration, and maybe some end-to-end if we get time. So unit tests, there's going to be an acronym called FIRST. Wait for it. They're fast because they're small. They're isolated. So if you run a bunch of unit tests, any of the tests don't affect any of the other tests. So it's an isolated test. Every time you run it, no matter what, it is always the same result. Repeatable, also same result every single time. They're self-validating. They validate themselves. And they're timely, which I feel like that means not only that they're fast, but they run. I just realized that timely and fast probably mean about the same thing, but it makes the acronym work. So unit tests, just remember first, the main thing is that they're fast, isolated, and can run all the time. So integration tests invoke multiple parts of the system together, may have external dependencies. You might not. Usually less deterministic if there are uncontrolled dependencies. So like, let's say you have a dependency on, let's go back to, I guess, the loan provider. Like, let's say you just service loans, but you don't actually book loans. So then you maybe have a dependency on some application or API to do the actual booking. And they're useful to test legacy code. Legacy code, I imagine in most environments, is kind of a bad word. I've heard it said once that legacy code is the code that you've written without any tests. So that's a definition that I've more or less used, but legacy code, hey, like a lot of our infrastructure still runs on COBOL, believe it or not. So I don't know how to test COBOL, by the way. I just know that was something told to me, and I researched that a little bit. But yeah, fun fact. So end-to-end tests, it's a type of integration test, but it invokes a system from its entry point to its end. So the entry point being whether it's the website or if you're writing an API for somebody, popular tools like Postman or Insomnia. There's other tools that are out there, but like some kind of API tool where you can go and make a REST request. And some of those tools have the ability to automate those tests as well. There's also, it will have external dependencies. Like if you're writing an end-to-end test for whatever application, you probably have a database. You probably have the front end. You might even have, like, let's say you have microservices or something. You have like all these disparate services that are all dependencies. So an end-to-end might contain a lot, and it will not be in memory. In memory versus not in memory typically is about talking about databases. I'll talk more on that a little bit later, but there's tools to use an actual database that's quick rather than using in memory, because specifically the example I have is in C# using Entity Framework. If you use the SQLite in memory database, it behaves very differently in certain circumstances than a SQL server or Azure SQL server. And so your tests will not actually reflect what will happen in production. And they're usually the slowest form of integration tests. There's going to be a graphic here in a little bit to explain how many to use, and I recommend not very many of these. Usually less deterministic if there are uncontrolled dependencies, just like an integration test. So, test-driven development. Now that we've got some definitions out of the way, as far as like testing, test-driven development, there's a book. I can tell you right now, I didn't read this book. I've learned from people that read this book and told me about it. So I'm just going to be full disclaimer on that one. I plan to read this book in probably the first quarter of 2025. But I read another book, the Extreme Programming Explained, I think, but it talks about test-driven development as well. I have a bunch of other books. I actually have a book with me, Accelerate, that is a great book for, it's data-backed, that like using test-driven development and trunk-based development, all these different things that are great. But Kent Beck, great author, great engineer. But test-driven development, first step, a lot of people miss this, is to think. There's actually 4 steps to TDD. A lot of people think it's write the test first. It's actually to think about what you're trying to solve. The second step is write a test that describes the behavior that you want to see. I guess I usually combine these two. You write the test and then you make it fail for the right reason. If it passes when you write the test before writing code, you probably, I'm not going to say probably, you definitely wrote the test wrong. Like it should not pass the first try. Like it should fail because it doesn't exist yet. Like it should either be a compiler or the actual logic doesn't exist to solve the test yet. Then you write just enough code to make it pass. I fall into a trap a lot. I've been doing this for a while. I still fall into the trap of whenever I hear requirements, I have the code in my head. I go to my desk and I start planning it out, starting to write it. And then I go, oh no, this isn't TDD. I'm already writing the code. Or when you're writing the code to make it pass, we actually did an event last week we called Code Retreat, and we were doing a little mob programming, and I had a nifty little way to solve a problem, and I started typing in the data structure before it was my turn, and one person was like, hey, why are you doing that? And I was like, I broke my rule, and I had to delete it. But yeah, you write enough code to make it pass, because it's very easy to over-engineer. A lot of times it's hard to admit, but it's very easy to over-engineer. I've done it so many times before learning TDD, and I'm still in a learning process. TDD, I don't think there's like a perfect, somebody in the world is perfect at TDD. Maybe Kent Beck, because he wrote the book, but it's an ongoing habit development. And then refactor. This is actually my favorite step of TDD. I feel like it's almost everybody's favorite step, because sometimes you'll get to a part where you're like, I'm writing code that looks like other code. I feel like I could consolidate this method or whatever. The refactor, this is when you do it, because your test passes with the logic that you solved with. So now you know if this test pass, I've solved the problem. But when I go to refactor, if it breaks it, you broke the test, it doesn't work anymore. So if you can get it to stay passing whenever you make refactors. I don't have the book on the slides, but is it Robert Martin? There's like so many Bobs. I think it's Robert C. Martin. He wrote a book called Refactoring that I think came out with a new edition last couple of years that's in JavaScript. So it's much more broader audience for like code, but it's all about how you can make small changes that every change that you make shouldn't break anything. So it's also a good book that I haven't read yet, but I watched him give a talk about it and then advertise his book. And then repeat. Just do this process over again. This is really fun to do if you at least have a pair, because then you can do what's called red-green refactor. You can have one person write the test, another person write the code, and then swap. And it's actually a fun activity. We did that at the Code Retreat event. We actually had 4 of us, and we kept rotating who was writing the test, who was writing the code. And it's actually pretty fun to do. And so here's the steps in a fancy graphic. So think, test, code, refactor, repeat. So what's not TDD? So I kind of hear this one a lot at places that I go as a consultant is like, yeah, we do TDD. We write tests. We do testing. It's not the same thing. It's a way of writing tests. It's not that you write tests. So that's just something to keep in mind. It's not writing all the tests up front. I've heard some people shy away from TDD because they're like, I don't want to write all of the tests up front and then have to like just look at red all day and then, make a Christmas tree out of your test graph. There's a lot of tools that do red and green. So sometimes they make it look like a Christmas tree and I have fun with it. But when you're doing TDD as a discipline, should only be one red, then green. And then also TDD does not mean no bugs ever. It means less. So we are humans. There will always be the chance of a bug, no matter what system we put in place, because we're human beings. Even with AI, I feel like AI is actually worse than a lot of programmers out there. That's just my first pass. I'm not trying to make oh my gosh, AI is terrible. AI is fine. AI is great. It's a great tool to help you program. But there's some stuff on the early days where it was just literally, I would not write that. But sometimes it would surprise me. But why would we do TDD? Because I bet some of y'all are probably wondering, why would I want to do TDD? Why would I want to write tests first? Why would I want to do this new thing? Because if whatever you're doing may have been working for you so far. I've heard it said by some people that are influences in my life that the system that you have today is designed perfectly to give you the results that you have today. And so if you're trying to affect change in your organization, affect change in your small team, or just affect change in your personal development journey, you got to do something different. I don't know if TDD is the thing, but that's my goal here today, is to tell you why I think you should give it a shot. You work in small steps. So if you think about it, you get the dopamine hit of when you get the red, and really quickly you'll get the green if you're just doing the small steps that are just necessary to make the test pass. If you follow that discipline, it's smaller cycles. You have less guesswork because you're starting from a place of what am I trying to solve, and then creating the answer. Also, it gives you focus on the requirement. You're continually focused on what you're doing, what you're trying to solve. Also, you think through failure states. I think it puts you in a mindset to think of what could happen if this happens while you're writing some of these tests? So you could be writing a calculator and what if I divide by 0 or something? And, when you're just writing the code to do addition, subtraction, division, you probably might not think of that when you're just oh, I got it. But if you break it down into smaller steps, it makes it a little bit easier to digest. Also, there's proof. Like I said, the dopamine hit, the proof that you added functionality. It was once red, now it's green. And then design feedback. If it's hard to write tests when you're doing TDD, the design might be wrong. That is a loaded statement, I will admit. But I've been at a few places now that it's been very apparent where if I take way too long to write a test, or to write a test and make it pass, there is something either too complex in the system to understand it as a developer, or it's maybe an architectural or a team problem where maybe somebody's written some spaghetti code and it's just really hard to add on to it. And so I have some strategies on how to start doing TDD. But design feedback, it's really quick to let you know if it's hard to write a test, you probably need to revisit your design. Doesn't mean you have to revisit the entire application, but maybe if you're trying to design something or write something, if it's getting hard to iterate on what you're working on, chances are it's probably going to need some time to step back and focus on it. In fact, I actually just watched a a video from a talk given by somebody. I don't know where it was given, but I could put the YouTube video on the link that's later that'll show up. But basically, this person was making the case that design at a certain point, having design takes time and it's a waste. It's not as productive. But then at some inflection point, having design makes it so that your product will take off faster. It makes more sense and it actually adds value. And it's really hard to find that spot, but it's a really good graph, really good, like maybe 2 or 3 minute blurb of their talk. But design feedback, if it's hard to write tests, it might be the wrong design. Often results in little time in the debugger. So one of my mentors said it this way, is that if you do TDD and you do it right and you hold to that discipline, the time that you would spend in the debugger trying to figure out what the heck just happened, you actually spend less of that time writing tests because you know what's going on, and you spend more of that time up front. I don't want to say more of the time. You spend some time up front so that you don't have that unknown amount of time figuring out what the heck is going on. Because one of the beauties of having automated tests is, let's say you encounter a bug. Well, if your test didn't account for that bug, you write a test for that bug, and then you make it pass, and all the other tests are green. You don't have to deal with that bug again. So, but yeah, little time in the debugger. I hate debugging. I like I said, Kent Beck's pretty cool. One of his quotes, "I'm not a great programmer. I'm a good programmer with great habits." So more so reinforcing that TDD is more of a habit that, I'm still working on it. I don't know if anybody here has ever heard of Atomic Habits by, I think it's James Clear. Just making 1% better every day will make you a lot. I can't remember the number, but keep it in that wire. 37%. That's what it was. Better after, I think, a year. So just focusing on getting better, and TDD is a habit. Also, this guy, Eric Elliott, pretty cool dude. If you haven't seen a test fail, you don't know if it works. I like to point that out because if, like earlier I mentioned, if you write a test and it already passes, that means you've probably already written the code to solve it before writing a test. So it makes it so that if you do TDD this way, you have a better understanding of what your system does as a whole, but also even in those little areas of the code where you're currently working. So you keep that context. So forms of TDD, roughly there's 2. One of them is called either bottom up or Detroit. Robert Martin has a blog post that I read about a month ago. I was like, where did this come from? And it's just, he mentions it as an aside. The other one's top down, aka London, aka acceptance TDD. So basically there was just a place in Detroit that the way they did TDD, they would start at the smallest level, unit tests, and work their way up to then integration tests and then end-to-end tests. And then top down is where you start with, I have an acceptance test. So if I want to test this application submission process, I write the acceptance test, and then I go in and write the code to solve it, which is a little bit different, starting at the bigger picture and then working down versus starting at the bottom layer and working up. There's not really a right or wrong one, just a preference. So bottom up, like I said, you build the bottommost layers first, start with a repository. So if you're writing a data layer, and then work up to the service or the handler, then the controller. And then this one's easier to teach. So let's say you are man, TDD is so cool. I'm going to take this back to my team today, but I don't know if my team is ready to learn this new concept. Bottom up is the easier one to teach teams typically. And then top down, start with a failing integration or acceptance tests. Like I said, you kind of write something that tests a feature in and or something. And then with a controller, this is, if you think of the model view controller, I was going to say framework. I can't think of the right word right now, but the frame of writing code. I blanked on it. But anyways, model view controller. If you start with a controller, that's kind of like the entry point into your code. Like if you're writing an API, that would be the gateway to the rest of the code. And then you write the service handler, the repository. It's usually full of mocks. I'm not going to take a stance on mocks. I know what I do, but I know that everyone has either a mock or no mock, or maybe a little mix of mocks and no mocks. And if you're not sure what a mock is basically kind of like a stub that fakes functionality so that you don't actually have to have the service to run the tests. So like I said, neither style is correct. Pick one that makes sense for you. I mix them. So I'll do the acceptance test and then do bottom up. So like I'll make a controller method and then I will go and then work on making it pass from the bottom up after having the test. So bottom up makes more sense to me too. So that's why I put it in there. But sometimes I delete tests at the end if I don't think they're useful anymore. Sometimes you'll write tests that you'll delete. More on that later. But sometimes you'll write tests that after writing some other more robust tests, you don't really need all of the ones that you wrote. And so you can delete them. But that's okay. Helped you to design. But knowing when to delete tests is probably a 400 level concept of TDD, but by default, don't. So I'm not the all-knowing I wouldn't even be the one teaching the 400 level on when to delete. It's like debatable, but like for the most part, if a test doesn't make sense, I try to make it make sense first. And then if I can't make it make sense, that's when I either delete it or I comment it out and put like some kind of way of tagging somebody on the team. Like, hey, can we delete this? Does anybody know more than me on this? I'll probably find help before I even get to that point, but by default, don't. How many? This graphic is not exhaustive, but as you can tell, end to end. So the number inside of the graphic is approximately how long a test should take to run approximately. So end-to-end test probably will take about a minute. If you can imagine a computer loading the page, going to the website, submitting the order, and then testing that the order got submitted, probably could take a minute if it's a fairly complex system. Integration tests, those might take a second. It might be less, it might be longer. It just depends on all the dependencies that you're pulling up, how fast your machine is or your build pipeline. Unit tests, they should be so fast. Like right now, I think I'm working on a client. We have about 2,000 or so unit tests in one of our projects, and they take on my computer. I have a M3, whatever. It's not it might be an M3 Pro. I don't know. It takes maybe 30 seconds to do that entire suite, which feels a little slow too sometimes. But the unit tests, they should go really fast. And as you can see, the comprehensiveness, this gets a little faded here. It's a little bit easier to see up close. Comprehensiveness, like end-to-end test is going to test a lot of different aspects of your app versus the unit tests. They're going to be more efficient because they're testing that tiny little piece of functionality. And as they all add up, they should cover. I'm not going to talk about coverage. I promise. Test coverage is a completely different topic. But sometimes I've seen testing diamond. So real quick, I'll go back. So this is the testing pyramid. And then there's the testing diamond. This is what happens when like you go to a client and they haven't really done a lot of testing. You typically will start with, well, let's write a bunch of integration tests and a few end-to-end tests so that we know that the system works after we refactor. And then you'll start to grow the number of unit tests to eventually look like the pyramid. But so there's also the ice cream cone. I don't have a graphic for that one, but somebody told me about that one a month ago. And it's basically, you might have a ton of end-to-end tests, like basically the opposite of the pyramid, but like they call it the ice cream cone because it's an upside down pyramid, I guess. But it was just a fun side quest. Yeah, I'll call it that. So why not use unit tests always? I'm going to see if this will play. I don't know if it's going to play. Oh, okay. I wonder if I just have to exit for it to play. Can I? No. Okay, well, I'm just going to describe to you what it does. Let me just get back into slideshow mode. So basically, this is a GIF, and this is a typical like door lock on like a door that you would open. And what happens in this GIF is basically the person comes up, locks it, and then it's a sliding door. I feel like that's like the best one to convey the difference between a unit and integration test because like it's a door. So you're like, oh, I know what a door looks like and how to lock a door, but then it's a sliding door, which is not probably as common as a regular door. So the lock doesn't work. The tests pass, the lock functions, but the pulling it together with the door doesn't work. So sorry, I couldn't get it to play. I don't exactly know why it didn't play, but yeah, it's a fun GIF. All right, confidence. We're going to talk about confident green. So if your build passes, why aren't you shipping to production? It's likely a lack of confidence. So if you have tests and they're all passing and you're not shipping to production, you probably don't have confidence in your tests. And it's likely missing some automated tests. So let's fix it. Okay, now why If that still doesn't make you feel more confident, now why? Just repeat. So this is one way to build confidence on your team with when tests are passing, you want to trust that they're green. If they're green all the time, every time, if there's a flaky test, you want to get that thing some head and shoulders and get it out. Sorry, it's a very quick, bad joke, but, or sell some blue, whatever shampoo, but flaky tests, want to fix them and turn them to be confident green and confident red. So sometimes when the build is red, how confident are you that the app is broken? If the flakiness destroys the confidence in tests. So like if you ever get occasional red, you probably don't trust that red test if it was green like 1 or 2 builds ago. When you have no confidence, that actually is a negative value on the team. It actually reduces the confidence overall on the team. It also just reduces, it just is a bad thing. So lots of time is wasted just rerunning it and praying, the rerun and pray method and debugging. So like there's been a lot of times in the past I've seen on teams where somebody's like, oh, we got a flaky test. I'm like, okay, cool. What'd you do about it? He's like, I just ran it again. That didn't fix it. So excessive investment in end-to-end tests often leads to lack of confident red. So if your first thought with TDD or with testing is I'm going to write a ton of end-to-end tests, as you saw on the pyramid, you don't want to have as many end-to-end tests because that'll take a lot of time and they're more brittle. They are way more likely to be brittle. Yeah. So this is a concept that one of my mentors shared with me. Has anybody ever heard of Chekhov's gun from like a literary standpoint? Basically, I think, yeah, the quote is, remove everything that has no relevance to the story. If you say the first chapter that there is a rifle hanging on the wall, in the second or third chapter, it absolutely must go off. If it's not going to be fired, it shouldn't be hanging there. Basically, Chekhov's gun, if you mention something, it should actually do something. Otherwise, don't mention it. With testing, Chekhov's gun, I'm going to kind of go through a couple of code examples. These are .NET, C#, but basically here we have a test and we're setting up this whole customer, but we're testing that it's a valid customer. And the validation is that there's an error message, last name is required. So this test by itself looks kind of fine, but it gets a little bit, is my pointer? Nope, it has not worked that well. Anyways, I have a laser pointer, it didn't work. But basically, you don't really care about SpongeBob being the first name or the address being 123 Pineapple or even the birth date in this particular test. All you care about is that the last name is not set. So what we're going to do is, first of all, highlight it. I should have done that first. But we're going to go and say, you know what? Hey, let's make a little wrapper that makes a valid customer. And then let's take that last name value and let's set it to an invalid value. Now we've reduced how much is in the test. So like think of if you have tons of tests, you're reducing the noise and the cognitive load for a developer to go in and look at the code, know what it's doing, and then be able to update it. Because like let's say they have to add something to the test or change the test. So now we're just setting the last name. But I think we could take it a step further and actually have the customer get set outside by default to be a valid customer. And then we only care about setting it in here. So now it's a field rather than just a little variable. So it's getting a little bit nicer, a little bit easier to take care of. Well, now let's actually set the customer validator outside as well. So now we're just reducing even more code that a person has to read to understand what's going on. And then if you compare the two, I would imagine if you can make the assumption that there's a setup inside of the class to handle setting the values by default to a valid customer, and that the customer validator is instantiated with its dependencies, the bottom one's probably easier to understand really quickly what's going on. Whereas the top one, you're probably going to spend a few seconds looking back and forth like, oh, is it first name or last name? Oh, so it just reduces the cognitive load when there's lots of tests to go through and look at. So how much should I test? If you can delete production code that breaks the app without breaking a test, that's a problem, because I don't want to say 100% coverage, but I do want to say if you can delete code and the app breaks without breaking a test, that means that it was not properly tested. Maybe we'll use that phrase instead of 100% coverage. We'll say properly tested, because if there's an area that's not tested, that's potential to go very badly, especially if it's not covered by an end-to-end test or unit test, integration tests. It results in people not actually feeling confident. Remember that confidence we talked about? And then unless the cost of writing and maintaining the test is prohibitively more expensive than the cost of lack of confidence, I would rather uh, sorry, the sentence is like kind of long and it just threw me off when I read it. Unless the cost of writing and maintaining the rest is prohibitively more expensive than the cost of lack of confidence. So like the confidence on a team, I think, is a very important and precious jewel to have, because when you start losing confidence on your team, you'll see the morale start to go down. You'll start to see, I don't know if anybody's heard of, is it broken windows syndrome, where basically the concept, I don't remember where it stems from. I think it was in New York there when Rudy Giuliani was the mayor. But I think if you have a building that has a broken window and it doesn't get taken care of, more windows are going to be broken pretty soon, because there was a study even done where they left a car that was pristine in the middle of a bad part of New York, and then they left a car that had like a broken window on it in the same spot at a different time, but still at night. The pristine car, nothing happened. It was fine. The broken window car was like demolished. The wheels were stolen off of it. I think this is referenced in The Pragmatic Programmer, also another good book to read. But basically the idea is if you reduce the lack of confidence, you start to have the like, oh, it's okay that that's broken. It's okay. Like just get complacent. So you could maybe say that lack of confidence increases complacency. Yeah. And if it is there a factor opportunity? There's something wrong with the test, implementation, environment stability. So like there's different questions to kind of ask yourself before to go and fix it. And then, is deleting logger code breaking your app? Oh my gosh. If you delete the logging code, it should not break your app. It's a very tiny detail, but if your logger is not, logging shouldn't break. Sorry, I just am very passionate about that, because I had a personal situation where one of my first jobs, a guy left and he had his email address hard coded in the logging logic, and they disabled his email, and you could say his name became a curse word. So how do I get started? How do I take this to my team? You might have this phrase in the back of your mind, but I don't have time to write tests. Well, do you tell this person to do it faster? You tell this person, hey, I need you to get this. I mean, like, sure, you have a surgery date, but like, you're not like waking up on the operating table saying like, hey, could you cut that a little quicker? Like, I need to be out of here by 5. But I'm not saying that what we're doing is surgery, but sometimes it feels like it. It feels like there's that pressure of like, if I don't fix this bug right now. But these are just questions to kind of help. Another one is sometimes people will say, my boss won't let me. And then my question is, then why do they want you here? They want you. Chances are every organization everywhere wants every software developer to write quality code. I'm posing the idea that TDD will help you and your team write quality code. So you don't get better at TDD by not doing TDD. How long did it take you to get good at, whether it's .NET, Node, whatever programming you do, how long did it take for you to get good at it? Don't expect to be like instantly really good at TDD tomorrow. Like you show up and you're like, I'm doing TDD. And then you just can't even write a test because you're like, I don't even know what framework I'm using. What's going on? New bug. This is one of my favorite ways to introduce TDD on a team is if there's a new bug that comes up in production, write a test that fails, that mimics the functionality in production that's failing, and then make it pass to prove that you fixed it. So then when it gets out of production, you've increased the confidence in that one green little dot or check mark or whatever the IDE you use says. So I'm going to real quick cover some tools. I don't think I have time to get into a demo, but I feel like that's probably okay. But I can take questions and talk more a little bit after this. I'll be hanging around for the rest of this awesome event. But some of the takeaways. So I don't know why it says tools and then takeaways. So my bad on the slide. I'll fix that on the upload. But some of the takeaways are what kinds of tests are out there, why you should TDD, what to test, Chekhov's gun, how to do the front end and back end starting TDD. So on the front end and back end, it's going to be more about the tooling. This is why the tooling is there. So like for unit testing, my main commentary on front end testing with TDD is, I think I said it earlier, like you don't have to I would rather test behavior, write a test for the behavior before writing the logic. So I wouldn't write a test saying, is the button visible on this page? And then write stuff. I would write, when I click the button, does it do X, Y, Z? And then it fails. Then I go add the functionality to the button. So like sometimes it's like easier for me personally. The way I do it is I'll sometimes do the HTML, make it look all like the way I want it to look. And then I'll focus any functionality that I do. Then I'll switch to doing TDD on the front end of like, here's the behavior I'm looking for. Or sometimes I'll even write like a end-to-end test that I'll run it. And then if it doesn't pass, then I'll go and work on it a little bit more. But some of the tooling, depending on what front end you're using, there's a really cool library that works with Jest or VTest for Node with React, Angular. I think it works with Vue, maybe even Svelte and a few others. But testing library makes it a lot easier to find things on a page rather than using IDs and all that stuff. And then testing Cypress, Playwright. I know that there's a few others out there, but those are the main two that I've run into. Backend for Java, there's JUnit. C#, I use XUnit. Microsoft uses XUnit, but NUnit's pretty popular too. Again, Jest and VTest if you're writing like Express Node backends. Integration testing, I highly recommend test containers because that is a really cool tool that spins up a Docker container of whatever you're testing against. If it's Redis or a database, Postgres, MySQL, MS SQL, whatever, you can spin up a container, run tests against it like a real database, spin it down, and boom. So it's one of my favorites. I use that a lot. Mocking, if you do mock, Mockito, I think, is a popular one for Java. I haven't really done a lot of Java, so if there's more, would love to hear other ones that people use that use Java. I mostly do C#, .NET, Angular, some React, Node, but in substitute and mock for C#. And then the Angular testing library, it's that testing library, but the Angular flavor of it. And then Jest is a pretty good, has mocking capabilities in it too. I don't think we have time for a demo because I believe, I don't know if we have a minute or two. 5 minutes? Okay. All right, let's see how this goes. I can do it. Let's see which way is my developer console. All right, so this is in C#, and I've got test containers in here. I've got an author repository, books controller, authors controller. Basically, I've got a get all command on both, or a method on the two repositories. That's all I've implemented. And I've got tests down here. And what I want to do is maybe just walk through adding a failing test and then make it pass real fast. I think I can do that in 5 minutes. So, or even modify a test that exists. So let's go without getting too into all of the inner workings of XUnit, .NET, and all that. I've got it basically wired up. I'll have a repo. I'll push up a repo to link to where that QR code goes. I'll make sure there's a repo there. So basically, I've got a test here that is calling my API. This is an integration or end-to-end test from an API standpoint. It's spinning up a server, spinning up a Docker container with a database, and then migrating the data the database so it's got the schema. And then I'm adding a test author and a test book into the database manually using Entity Framework. That's another thing. I don't usually test frameworks. So like Entity Framework, I don't write tests around like, does .add X work? I just test the results and things that I do around it. So in this test right now, it's adding an author and a book. The author's name is Bilbo Baggins. The book is The Hobbit. Right now, the book I added on the book, the author is Bilbo Baggins to make that relationship there. And so this test, when I run it, I think I can sweep over here so you can see that a test container spins up. This is Docker, by the way. Test container spins up, have the database up. I'll go back over here. The test already finished in like half a second. So I already know, because I did this ahead of time or prepared this code ahead of time, that I believe this test is going to fail. And I know why, and I'll walk you through how I can make it pass really fast. So this test, if I run it now, you would imagine that the author name should be the same, but I didn't do a certain thing to make it the same. So it failed because I'm getting a null reference because I didn't return the author objects, the relationship with the book. So real quick, all I got to do is go back to the book repository and add a .include b.author, and then the magic of the demo.
Something's happening.
Oh, that's cycle. Oh, interesting. That's a different area. Anyways, that should have worked, but it didn't. So the beauty of the demo.
No, we're live. It happens.
Yeah, there's something to do with the JSON parsing that I think that is another problem completely separate. Well, I don't know if you want me to try to fix that part really fast.
I'll follow your lead, Patrick. Oh, that was good information.
Yeah. No, I know it was a lot, but it could also have to do with my setup of the relationship in the DB context. So I don't know if I'll be able to actually troubleshoot that. That might actually be like a more of a like 5 to 15 minute fix, but
Oh, you're good. Patrick, thank you so much. I mean, that's good information talking about just how testing's kind of a mindset, behavior. I love it. But yeah, any questions for Patrick regarding testing, unit testing?